In this video, we're going to look at psychrometric channels. Let's take a look at an example where that might be useful. I have an air handler here with mixed air, humidity and temperature, supply air, humidity, temperature, return air, humidity and temperature, and outside air. And I'd like to look at how much energy it's consuming. So as a quick example, I'm going to make a chart of the various temperatures. So look at mixed air, supply air, return air, and outside air, for example. And then take a quick look at what it's doing. Zoom in a little bit more. So these are daily cycles here. The green outside air temperature goes up and down. Highs of about 64, 65 degrees during the day, lows around 50s. And this is a 24/7 unit that has both temperature and humidity control. And here's the return air temperature, so the rooms are pretty steady at 68 to 70 degrees. But even at night, I can see that the air handler is cooling down. So it goes from this blue line, which is around 70 for return air, down to about 58 or so for supply air. So it's always cooling. In this half, it's using outside air, and so the economizer cycle is active at night. In this half of the picture, it's not active at night. So the mixed air temperature, which is dark blue right there, suddenly jumps up all the way to return air temperature. So if I wanted to see, so somebody made a change to the control logic of this air handler, and now the air economizer is no longer active, and I want to get some kind of quantification of how much money that costs. And the best way to do that is to figure out the tonnage of cooling that the air handler is providing. Since I have humidities as well as temperatures, I can actually look at how much dehumidification is taking place as well. Rather than just looking at temperatures, therefore, I'm going to look at enthalpies. And the easy way to do that is by using psychrometric channels. So I'm going to make a psychrometric channel and use just one of these as an example. Obviously, I would have to make at least mixed air and supply air if I wanted to do the calculation by multiplying by the airflows. But I'm going to just do this example here. So here's mixed air enthalpy. And the first input that the UT wants is atmospheric pressure. So I'm going to create another fixed channel here, constant channel, which I will call atmospheric pressure. And it's going to be 14.7 for 14.7 psi at atmospheric pressure. And I'm going to use that in here. So select atmospheric pressure, there we go. Then the dry bulb temperature, since I'm using mixed air enthalpy here, will be the mixed air temperature. There's that. That's my second input for temperature. The output I want is going to be enthalpy. So I can select all of the various psychrometric properties here. So I'm going to take enthalpy. And the third input next to pressure, dry bulb temperature is going to be my mixed air humidity up here. So my third input is mixed air humidity. I will tell it what that is. There it is, relative humidity. And that's it. There's my mixed air enthalpy. I can plot that along with the other quantities. Zoom out. There's the enthalpy. Maybe I'll show it on a separate pane. As we saw in a previous video, you can make separate panes in here in the chart and assign it to not the primary pane, but the one I just created. There's the enthalpy. So if I zoom in a little bit on this, there's my pattern of outside air and return air economizer, and here's the enthalpy that goes along with it. So now if I do the rest for the supply air as well, multiply by the airflows, I can get the tonnage of the air handler very quickly with the built-in psychrometric formulas.